Hey guys, you are welcome back to my YouTube channel. In today's video, we are going to be learning the concept of calculus. Calculus is a branch of mathematics developed by Leibniz and Faraday, and we have two major aspects, which are the differential calculus, and the integral calculus. We have the differential calculus and the integral calculus. However, in today's video, what the aspect I'm going to be talking about today is the differential calculus. I'm going to be talking about this today, and I want you to follow me. Okay, I have this differentiation. Differentiation is the mathematical process of obtaining the derivative of a function. You get it? So differentiation means derivative. Now, before I start, I want us to talk about the concept of gradients. I want us to talk about the concept of gradients. I know you will have heard gradients, but if I tell you that gradients, also known as slope, is also dy dx. Let's assume that we are given two these coordinates x1 and y1. We have another one x2 and x2 and y2. Let's assume that we are given these coordinates. On our graph, this is how these coordinates will look like. We are going to have something like this on our graph. We are going to have something like this. Of this is the y-axis and this is the what? X-axis. When at x1, I have x1 here, I have x2 here, and I have y1 here and y2 in this place. At x1 and y1, I'm going to have at this star x2 and y2. I'm going to have this x2 and y2. I'm going to have this. Now, if you look at this graph, you will realize that I can, if I want to find the gradient of this line, first let me trace like this. Let me trace another one like this. I will have something like this, and I will have another one like this. Now, this line, the slope of this line is what is called the gradient from this point to this point. Okay. Now, I have plotted these coordinates. I have plotted it on this graph. Now, if I want to find my gradients, don't forget that gradient is rise over run. So if I want to find my gradient from this point, I can easily say that from this point, rise, which is what? Dy, change in y, that is change in y, y2 minus y1, change in y, which is the rise, change in y, and from this point, I can easily find the gradient here also, which is also what? Change in x. So I'm going to have what? Change in x. And don't forget that the gradient is known as rise over run. Rise all over run. Which is what? Now, the rise is this and the run is this. So the vertical line is the dy. So I'm going to be having dy all over runs, which is what? Dx. So if you look at this, you can easily find the gradient of 2 points by using this. That is, dy dx is also known as what? Dy over dx is also known as what? Change in y. That is what? Y2 minus y1 all over x2 minus x1. So this is the gradient of this line. That's it. That's the gradient of this line. Don't worry, I'm going to be applying this. I'm going to be showing you how we apply this when we are told to calculate gradient of two lines. Gradient of a line between 2 points. I'm going to be solving question on that. But this is how we derive dy dx. This is why they call dy dx as gradient, and gradient is also known as slope. Kindly follow me carefully.